Hello, Dr. Mike here for Introduction to Computer Forensics, my CIS-2808 class. This is Topic 6 on Windows, Data, and Operating Systems. Specifically, the parts of Chapter 4 of our text that goes into Windows file systems and prefetch files. So there are other topics specific for Windows like Registry, file carving, which we're going to cover later, Registry being definitely a big one. However, we will be looking at, again, this is Chapter 4 in the text. Now, Chapter 4 is going to start off with some talk about the FAT file system. I have a cheat sheet here which I downloaded, and I'm not going to go into FAT file system in this lecture, but the text does kind of talk about it, and it's good to understand at least its basics. It is seen still around on a lot of thumb drives, external drives, and so on. So understand how we find the FAT table and then the FAT directory entries, the extension, attributes, and so on, file size, dates. So these are important aspects of file metadata, like creation dates, last access dates, and so on, that will be used for evidence. But we're going to move along and talk more into Ntfs, specifically the master file table, the Mft entry. Or Mft entries. So Ntfs, of course, being really the cornerstone, most widely used file system on Windows. Windows, probably one of the most widely used operating systems. There's a really good chance you will find Windows as evidence, and we'll need to collect evidence from it. And I know we talked about Windows file systems, Windows artifacts. Definitely not going to get into parts about the user itself, which would be, of course, files and their metadata. I say metadata, I mean like image metadata, Word doc metadata, like the properties of a Word document. The metadata we're going to talk about is going to be areas of the operating system to help users out, but also give evidence. So when we talk about Ntfs, we will talk about metadata about the files that Ntfs exposes. And again, there's some areas we're going to talk about that are not in the text, but I'll just mention here. And you'll see some of these in the labs too. Actually, the labs that go with this topic do talk about some of these aspects. Now, one of them, of course, is the prefetch file system. So prefetching files is a way for performance. So when we turn on applications in Windows, it prefetches part of the code and helps it to launch faster. So most commonly used files will have a prefetch file entry. I'm not going to go into the details of that. Actually, the lab does a great job of demonstrating how to fetch prefetch files. But this is an evidence item of who launched what application when. So again, this is an operating system artifact that does deal with what the user does, but it's not a direct user artifact. I say user artifact. The user will produce, for example, docs, maybe text files, emails, and so on. Right? Word documents, text files, emails, and such. Browser history, definitely one of the big ones. These are artifacts from the user, but when the user does interact with the operating system, like with prefetch, it does create these artifacts that are used for evidence. So prefetch file system is one of those. Shadow copies and restore points. So very common. Restore points themselves could hold evidence. Shadow copies could also do that too. We do cover that in the lab itself also. So I'm not going to detail those here. I don't want to do what the lab will show you. But definitely two areas I want to look at: prefetch file systems and shadow copies. Of course, they're pretty obvious. Recycle bin. Again, this is an operating system function that will sort of hold that user. When that user does things, they might delete a file, but also deleted files. So recycle bin, pretty obvious. We know what that is. All operating systems have some sort of recycle bin function. Of course, if they haven't emptied it, that's free access to what will be thought as deleted files, easy to restore. Print buffer is definitely a big one too. If there's a lot of printing going on, they can hold evidence of what file was printed when and who printed it. Now deleted files also. If the file is deleted and not in the recycle bin, it is still on disk. Now that's actually called file carving. So doing an analysis of deleted files and file carving are part of the file system. So we'll see here in a second where we can find if a file was deleted or not in the Ntfs records. I'm not going to go into file carving. That is topic 10 and 11, and deleted files. Those are for future topics, but we can see where deleted files are marked as inactive or deleted in our Ntfs records. So again, we're trying to bring this back down to these tools and utilities that we use to find these artifacts. How does it know? Where does it look? And here we can see this is a quick summary of what some of these records look like, so you can see down to the bare bones of how operating systems either hold evidence that was thought as deleted or thought as removed. So a big one, of course, is registry. This is probably a huge one. This is actually topic 7, which is the topic after this one. As you can guess, registry is one of the main backbones for our operating system, and this is really the mainstay for when the user interacts with the OS. There's a lot of registry entries for each user to our system for applications and documents and so on. So again, huge artifact from Windows is registry. It is mentioned down here in this chapter again, but this is covered later, so I'm not going to cover it here. It is worthy of its own definitely its own lecture material. So, all right, so we covered the basics there about those items, which would be Windows file systems and Prefetch. Now the file system itself, again, the big one is Ntfs, and a big part of that is the master file table, the Mft. So previously we talked about boot sector information. I'm not going to cover that here, but a big part of that here is location of the Mft. And actually, there's actually multiple Mfts or master file tables. There's a backup and a main, and these are part of the master boot records. The Ntfs boot sector has the location of these. So, and that's in a separate video. We talk about boot records and bootloaders. So information is there about that. We're going to go to there. What we're going to talk about really is this, the actual Mft record. So to do that, we'll take a quick look here. The textbook's going to cover a couple of main items, these Mft entries. First one being the signature itself. Now these are hexadecimal codes, so we're looking at hexadecimal. There's a video earlier about how hexadecimal, what it is. I'm not going to go into what it is here, but we will see it being used. So I'm not going to read the text to you, but you can see the Mft record is broken into several parts. Standard information, attribute list, file name, object ID, and so on. The actual data itself, and how we find those, or how it's found by tools, I should say, really more appropriately. How this information is discovered by the tools you use. So, textbook's going to cover some detail about that, and I will give you a summary of that here. So, now what I have here is a DD image of Ntfs, a small Ntfs image. So one of the tools we might use is fsstat. Real common tool I'm using right now. This is a sans SIP workstation. fsstat is installed manual. Looks like it was installed already. This is basically our way to go ahead and sort of scrape the information about the image to see its kind of file system it is. In this case, it is Ntfs. Some important if you're going to dive into any kind of file system. Deep dives on file systems, you want to know what it is. That'll help you determine what you're looking at. But we can see here it is Ntfs, and there's a volumes number here, and this is probably an important evidence item. So along with that, and like an MD5 hash, which we haven't gotten to hashing yet, but these sort of components you can see are really going to be a cornerstone of identifying a piece of evidence. And again, if this was evidence, this would be a copy of the actual drive, which the copy would have been made through either a read-only or write blocker process, and it will be verified to be an exact match using this hashing here of that. So again, I don't dive into original evidence. I'm using a copy of the evidence. So we can see it is Ntfs. There's information here about our cluster size and size of clusters. Some of this information could be valuable if you're going to go into your own file carving. And what we can see here is the attribute list. So we can see that here there's a standard information, attribute list, file name. You can see this is the Ntfs Mft entries. Now I'm just going to talk about how this is laid out and how this is extracted by some tools. Now, I say some tools, there's a lot of tools that do this, both commercial and open source. One of the tools you'll see is Mft Viewer, and this is actually done in, currently at the time of the recording, this is done as part of this class. But this is an open source Python tool that goes in and it'll pull out information about the master file table. And we can see information from that. In this case, is it a directory, is it active, inactive, created, modified. Here are these date timestamps. Again, date times are a very important aspect for building a timeline of evidence. And so you can imagine very important aspects here. But where does this come from? So what I'm going to do is, I'm not going to get into every detail of this. I want to give you an example of what these tools do. There is another video linked, I think it's from Jonathan Adkins, linked in the course shell, that goes really more into detail about reading this directly from a hex editor. So I'm just going to give you a sort of slight bit of this here. Alright, so if I open this, let's close this here. I'll leave it there. So if I open this Ntfs DD image in a hex editor, we search for what's called the initial Mft header itself. So we have our file record segment, and it's composed of several parts. And it does start off with the first 4 bytes with the code 46, 49, 4C, 45, and the 30 here. So in this case, the word file. And we can see it here in the text, the ASCII sort of from the hex here. That denotes the beginning of the Mft record. And we can see here I actually have a reference up here as Mft file record. And we're going to see here's the same part. So I'm using this web page. This is flatcap.org, Linux Ntfs attribute list. There's a lot of information out there to find Ntfs records, about Ntfs records, definitely in books and reference documents and so on. So I just ran across this. I found this is a good one for demonstrating this. But you can see here it talks about how everything's offset. We have an end of file marker here, marked by hexadecimal of Fs here, which you can see down here. So we have an end of the record. But this record begins with this file attribute here. And we have what's called offsets. And we offset out to offset 10, in this case, or ID 10, and then we use this to determine, in this case, the first offset is the standard information block. So what Ntfs does is it takes at least a minimum of 48 bytes, but a max of 72. But we can determine how big the block is, how big, where it starts and how big it is. So by first off, we find the record itself. So here's our first file record. We go to offset 10 here, and you can see here's our first offset, and we count in the 4th and 5th byte. So 1, 0, 1, 2, 3, 4. So we have 0, 0, 6, 0, right? 0, 1, 2, 3, 4. I'm sorry, we have 6, 0, and 0, 0. So that is an indicator of the size of, in this case, the standard information block. So we know it starts here, but how big is it? Now we take this 6000, and this is actually encoded in called Little Endian. So we read it backwards. So we have 00, and then we have 60. We put that to decimal, and we have 96 bytes. So Ntfs stores a marker, in this case 10, and then the 4th or 5th byte in, red little endian, to convert the decimal gives us the size of the block. Now I'm going to count out 96 bytes here, but 96 bytes of this, which is back to here, I believe, will give us the size of the block. So they can vary. So we'll clear this here. Now, of course, one of the things you'll come across in these records, of course, in this case, we see in the standard information block is file creation times, and altered times, and so on, when the file was read. So there's 4 file times here. We see those laid out here. So here we have the first file time, and the second, third, and fourth. Now it's all the same, so it looks like this file was basically created, not changed. But we could take this time, and again, we take these bytes. Let's see if I can bring it up here. File creation times. Take those bytes, and we can plug those into hexadecimal. Now again, this is read as, again, little endian, so it basically reversed. So we read this in. We can take this decimal value, in this case this hexadecimal value, we can copy it, let's grab that right there, that right there, 01, so there's our file time. There you go. So you can see that's been read in here. I can grab that hexadecimal, and we can go to basically a converter, paste it, and convert that, and I get a decimal number. Take a decimal number, and we can actually use this decimal number. It's called epoch time. And we can plug that in, and I'm using UTC. Now this is going to depend upon our file system, but basically plug in UTC and we can get, in this case, Thursday, May 6, 2010, we get the time converted. So this is where those times are stored. Now again, we saw with the Mft Viewer, a lot of other tools are going to go and do this for us. It's going to use the times it gets from the information about the system, and of course the date time of the system, and of course the time zone. So these are basic evidence items that are very important we collect, as you can see why. They might be fed into other tools. So, but I can get the information here. And this is again Thursday, May 6, 2010. 7:32:46 a.m. So this is using UTC. So you get, this is giving me an example of how these date times are extracted, and we can see those in here. So we can go further down here. We go to block 30. And from 30, again, we can count out byte 0, 1, 2, 3, 4, and 5. In this case, it's 7000. So again, if I take 00 and 70, convert that, it's 112 bytes. This is for the file attribute, the file name record. So again, the file name record is, in this case, is 112 bytes. With the offset of bytes 4 and 5, we can determine that. It begins with the flag here. You can see the ID of 30. So in here is the file name, as well as some other information too. So here we actually can see the file name, file1.jpg. So an important aspect of this is the file name object itself will help us determine the extension that was given to the file, but there are ways to determine if the extension is invalid. So, and I'm going to go into later. There's ways, they're called a file signature. It's hexadecimal code given to the actual file data. And then, but even though if I call it .jpg and it's a .doc, it's sometimes to hide their files. We can use those to find these sort of misnamed file extensions. So again, there's tools for that, but you can see where it comes in. Again, if I look at the attribute name here, file name itself starts at 30. Again, and then we have the times also in there, as well as the file size. So there's a lot of aspects to this with file size and also with multiple entries. It's going to depend on if the file is resident or not resident. If the file is very small, it's going to keep the data itself. The data block will be part of the MFT record. If it's a larger file, though, this will point to the block that actually has the data. So there's a lot of complexity here with that. So there's anything called residency. And I believe it's one of the flags that we have about a file right here. So if it's resident or non-resident, very important flags. Is it encrypted? Again, a very important flag. Is it compressed? And so on. So we have flags that are going to be used, and they're part of our flags field here. And then some other attributes about our file. Very important to look at. In this case, we have an attribute in the file name attribute. So back here, file name attribute block. We have, of course, real size of the file, but here we have, if it's this case byte 38, it looks like, we have some flags. And we will flag it if a file is actually active or not. Is it a temporary file? Is it a normal file? Is it a device file? And so on. So there's a lot of information packed into these data blocks. Then we have actually a flag if it's a directory or not a directory. Also, we have a flag if it's in use or not. So, very important things here. Not in use. A flag that's not a file that's marked as not in use is sort of tagged as deleted. Now, again, the data block can be overwritten later, but this is the chance where we go back in to talk about finding deleted files. So we have an Ntfs Mft entry that will be tell us if it's active or not active, or in this case, it's in use or not in use. So not going to get too much in depth. There's a lot of information here, as you can see, our attribute list. Basically, standard information is going to have stuff that starts off with the file. In this case, the word file, uppercase, which again is 46, 49, 4C, 45, and hexadecimal. And from there, we have these different blocks that help us read out and are used for calculating things like file date times, if the file is active, not active, file name, and so on. So again, the data block is going to be a lot of dependency here. It's going to determine if the file is, if it's resident, we'll actually have the data for the actual file itself. If it's non-resident, then we'll be further out in different blocks or further other blocks. So last few things here, of course, we have index information, bit mapping, reparsing, logging, and stuff like that. So Ntfs has a lot of stuff in place for journaling that helps maintain file integrity. So a lot of information is packed inside here to sort of maintain integrity of the file. So technicals are ready. Again, if it's encrypted, unencrypted, if it's archived, or so on. And these flags you see a lot of times are also in multiple locations. And there'll also be multiple entries. So if we looked here, we'll see the word, we can see there's multiple entries sometimes for the file name. And this is normal because Ntfs will keep what's called the old DOS file name, which is the old 8.3, right? 8 characters for file name and 3 for the extension. And this is definitely old school here. Then we also have the longer file name stored in another file name entry. So you'll see multiple entries sometimes for file name. Then we have the long file name, which we normally see as end users write, really long space file with spaces and so on. So there will be multiple file entries, file name entries too, used by Ntfs. So this comes down to the end of the file marker. Again, in our case, we have Fs here to end the file marker itself. Again, if you go through, you can find, in this case, here's the beginning of the data block. and count to bytes, again, 4 and 5. So 0, 1, 2, 3, 4, 5. We have 18, 0, 0. So we have 0, 0, and then we have 18. Oops. 0, 0, 1, 8. And so it's 24 bytes. In this case, it's probably not, this file, being a JPEG file, is not resident. It's too large just to be here, so we probably have the identifier for where this file's at. So again, file name is not information. It sounds like file name would have just the file name, but I think what I want you to take away from this is file name. The file name block has a lot of information, directories, these modified dates, logical file size, and all these flags, and then we get the actual name. So the data block itself, again, if the data block is, if it's a resident or non-resident, it's very important. That's a flag. If it's non-resident, it's not going to be part of the Mft entry, so it'll be further out on disk. And that's it. So again, there's another video that goes way more into detail about this. This is just a quick sample I tried running here, using some basic conversions manually. Again, you can use a calculator. Just be aware of these entries and how they're laid out and how they're read too. Again, you notice again how the date times are a little Indian, so they laid out. What we see this way is actually read backwards, and use that way to compute. So again, so that's sort of like really just the tip of the Ntfs iceberg, and hopefully the textbook itself will give you some more information here that I'm not going to go into, as well as any supplemental videos I've made posted in the course shell. So that wraps up a very quick summary of the Windows file system and Ntfs, and with some discussions about other things, prefetch files and shadow copies and so on. And that wraps up topic 6, and thank you for watching.